Hi guys, in today's video we're going to take a look at period 3, looking at where is period 3, structures in period 3, the trends of period 3, looking at trends in melting point, atomic radius and ionisation energy, an exam style question, and finally a summary.
So let's begin by just recapping where period 3 is. Remembering that our periodic table is divided into horizontal rows or periods. Period 3 is the third row down. It begins with sodium and ends with argon. We can take a closer look at the elements in period 3. We'll take a look at their structure. From sodium to aluminium, our elements are metals. Sodium, magnesium and aluminium, you may well know, are all metals. Silicon, the next element along in the period, is a metalloid. Some of its features are similar to a metal and some differ. Our non-metals are phosphorus, sulfur and chlorine, and argon is our incredibly stable noble gas. So now I've had a look at the structure of the elements in period 3, let's take a look at how the structure and bonding influences some of their physical features, looking at the trends that we observe across our period. You can see that we observe a trend in the melting point of our elements within period 3. As we move through our metals, we see a steady increase in the melting point. We peak at silicon and then dip back down for phosphorus, sulfur and chlorine, our non-metals. And argon, our noble gas, has the lowest melting point of all. So why do we see these trends? Well, as we move through our metals, from sodium to magnesium to aluminium, we see a steady increase in the melting point. And this is because the ionic charge, and so the sea of delocalized electrons, increases. Our sodium atoms form ions with a 1+ charge, so for every sodium ion there is 1 delocalized electron. For every magnesium ion there are 2 delocalized electrons, as the ion takes a 2+ charge. And our aluminium ions take a 3+ charge, so for every 1 aluminium ion there are 3 delocalized electrons. As a result, the strength of the metallic bonds in our aluminium are stronger than that in our sodium, and therefore the melting point increases as more energy is required to break these metallic bonds. We can see that silicon has the highest melting point of all our elements in period 3. This is because silicon has a giant structure. Between our atoms of silicon, there are strong covalent bonds that exist throughout the 3D structure. These covalent bonds require a lot of energy to be broken, allowing for a high melting point. We then dip back down for the lower melting point of our non-metals. Now, the melting point of our non-metals depends on the size of the van der Waals force of attraction between our molecules. And this itself is dependent on 2 main factors: the number of electrons in the molecule and how closely the molecules can...
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, just click the Snap Provide smiley face. Join me today and together let's make A-level chemistry a walk in the park.